So in this final video in the series on Boolean logic, we're going to look at applying logical operators in truth tables in order to actually solve a problem. So it's quite likely in an exam you may be given a scenario, and off that scenario be asked to write a logic diagram, a truth table, or possibly both. So with our scenario, we're going to say that a fire alarm goes off if either the temperature inside a building rises above 60 degrees Celsius, or someone manually smashes a fire alarm glass panel. We also want the situation where a fire officer should be able to manually shut off the fire alarm regardless of the previous two circumstances being true. So that's our scenario. Well, the first thing is we're going to have to construct this logical diagram based on the three gates that we need for GCSE, and that's not, and or. If you're not sure what these are, pause the video and recap the previous video where we covered these. So I've created the logic diagram here for our scenario, and let's just work through it carefully to check that everything in the scenario is correct and this logic diagram actually behaves as we expect. So I've changed the colour of the various images here to black and white, and that indicates that input or output is currently off or not active, and that's being represented here by a 0. So this is our initial state. The temperature isn't above 60 degrees, so we've got a 0 there in that OR gate. No one smashed a fire alarm point, so that's a 0. And our fire officer hasn't activated the manual override, so the fire officer also is inputting a 0. Of course, that means the NOT gate then flips a 1 out the other side, but that's absolutely fine because the fire alarm only goes off if both those gates are active. So now we see the situation where the temperature has risen above 60 degrees Celsius. So we've now got a 1 or a positive input to our OR gate. We only need one input for an OR gate to be true, and the output is true. So now we have a 1 coming out of an OR gate, a 1 coming out of the NOT gate. This means the AND gate at the end is receiving two 1s, and therefore output 1s, and the fire alarm goes off. In a similar situation, here the temperature is below 60, so the input is 0, but someone smashed a fire alarm point, so that input is a 1. We have exactly the same situation. We have a 1 out of the OR gate, a 1 out of the NOT gate, so that's two 1s into the AND gate, and the fire alarm goes off. It works if the temperature is above 60 degrees and the fire alarm's been smashed, and you'll see that's perfectly fine. And the final line of our scenario is that the fire officer has come along and has manually shut off the fire alarm. So he's providing an input of a 1 to the NOT gate. He's activated the manual override. The NOT gate flips that 1 to a 0, and that now means the AND gate is receiving a 1 and a 0, which means the output from it must be 0. So the fire alarm turns off. So the next thing is to turn our logic diagram into a truth table. Well, the first thing to do here is to replace the diagrams, and let's start using letters because these are going to make more sense in our truth table. So I've got three initial inputs, A, B and C, and I've got one output at the very end, D, but I've also got two intermediate outputs. I've got the output from the OR gate and the output from the NOT gate. So I've labelled them E and F. So the first thing to do is to construct the various columns for our truth table. So let's start with all the inputs, that's A, B and C. Well, that's nice and easy. We've constructed three columns in our truth table and we've labelled them A, B and C. We now need columns for our intermediary outputs and inputs. So we've got the output of A or B, and we're going to call that E. And of course that will end up being one of the inputs to our AND gate. In a similar way, we have the output of not C, and we're going to call that F, which becomes the other input to our AND gate. And then finally, we have our output D, which is the result of E and F. Now we've constructed our truth table, we can start to fill it out. So the first thing to do is to fill all the various combinations for our three inputs A, B and C. And as mentioned in a previous video, the easiest way to do this is to simply count up in binary. For the first row represents 0, that's 0, 0, 0. The second row is the number 1, 0, 0, 1, and then 2, 3, all the way up to 7, which is 1, 1, 1. We can be sure we've got every possible combination of three inputs there because we've gone from 3 zeros to 3 ones. So now we start working through the truth table. Let's start with the OR gate. So the OR gate takes in A and B, and remember, either of those should be 1 and the output E should be 1. So you can see I've filled that out here with zeros and ones as appropriate. Now I'm dealing with a NOT gate. This only has one input, that's C, and it's dead easy. Whatever's in C is flipped and knotted to be F. So the zeros become ones and the ones become zeros. And you can see I've done that there. We now take the final AND gate, and that takes the inputs from column E and F. And remember, with an AND gate, both inputs E and F have to be 1 for the output D to be 1. And you can see I filled that out there.